Hey Math 8 students, so this Khan Academy, Pythagorean theorem in 3D. Hey, there's sometimes there's assignments that if you can get them done and do them correctly and understand them, you can feel really proud about yourself. This is one of those, okay? This first one I mark as the easy example. It's not that it's super easy, it's just compared to the next example, this is the easy type to do, okay? So basically here, I know this and this diagonal and here doesn't make perfect triangle. But imagine if this slanted line were right here instead, then this whole thing would make a perfect right triangle. Hopefully that makes sense to you. In order to solve for the h, we just need to use Pythagorean theorem, but in reverse, where we do the c squared side, this part right here, minus this side right here will equal this. So what is the length of half of this distance right here? If the whole distance is 6, then half would be 3. All right, so let's do our Pythagorean theorem then. Again, we're doing c squared minus a squared will equal our b squared. Our c squared side is 3 square root of 2. Our b side is 3, and we're going to square both of those. Now here's how this works. You know how to do this one. 3 squared is going to be 9, so that's pretty simple. But when we take 3 squared here, the 3 will square and become a 9. I think that makes sense. But when we take the square root of 2 and we square it, the square root and the square will cancel each other and just leave a 2 in its place. And I put it in parentheses because we then need to take and multiply these two together. And 9 times 2 is then 18. So, again, square this number, you get 9. The square and the square root cancel each other, leaving a 2 left over, and then we take that 9 and that 2, we multiply them together to get the 18. We then do the 18 minus 9 is 9. We then do the square root of 9, which is 3. And so we know that the height of h is then 3 units long. Okay, that's the easy example. Now we'll go to a more difficult, the hard example. If you can get this, feel very proud of yourself. We need to figure out this diagonal length of d right here. Okay, so this part is what we've got to figure out. In order to do that, you might notice this diagonal length here, then straight up and down to here, and then this cross diagonal here would make a perfect right triangle. So we literally need to figure out the distance of this cross unit right here, if that makes sense. So you can see where I'm drawing that here. So in order to find the length of that red line, you might notice that this red line, this side here, and this side here, the 2 and 3 side, makes a perfect right triangle. So we first, just in order to find the cross length, have to do the Pythagorean theorem with this one. It's not what we're ultimately looking for, but it's what we have to use to get there. So 2 squared plus 3 squared is equal to 4 plus 9, which is equal to 13. We then take the square root of 13, and it's not a very nice number, so we literally leave it as square root of 13. Meaning, this cross length here, the distance of that, is seriously square root of 13. Now, we know that this is the square root of 13, and we're trying to find this d. That means we've got to fill in this information for this line. Because this line over here is a length of 6, we know this length over here would also be a length of 6. And so that's my yellow line I've got here. Okay, so this side is square root of 13, this side is 6, and we've got to find this diagonal. So again, we'll do Pythagorean theorem. A squared plus b squared equals d squared in this case. So we'll do that. We're going to take our a squared side, the square root of 13 squared, plus our b side, the 6 and squared, and that will equal our d side squared. Well, square root of 13 and the square will cancel each other, leaving a 13. 6 squared is 36. We will add together the 13 and the 36, which is 49, and then take the square root of 49, which is 7. 7 is our ultimate answer for the distance from these two. I know that's more complicated. You're going to need to definitely use me for this to check your answers. When you got that, though, it should go pretty well. If you make it, good job. Bye-bye.